so much, Vikas, and thanks so much, everyone, for joining this webinar. Like Vikas mentioned, I take care of network and security BU for VMware India. I've been with VMware almost close to 12 years. So today in this session, what we're going to do is we're going to talk about NSX Firewall and how we can help you secure your data center. While NSX is a product, but primarily we're going to talk about features, functionalities, what are use cases it can help you deliver into your setup. And like Vikas mentioned, we have a panelist on Q&A. Please go and type your questions there. Ankit, he's there to be able to help you answer those Q&A. If there's anything that needs, you want me to take up during my session, please raise your hands and maybe I'll pause at few slides and take it up. So without much ado, let me quickly get into my presentation. So, when you talk about security, right, and NSX is actually an SDN platform that came to VMware around 2011, 2012. So currently, as we speak, we are probably into 7th or 8th generation of NSX software. So it's a pretty mature software. But when you look at the security, right, security from a legacy perspective, it's still divided at perimeter. That's how, the security is looked at. And there is one element which is outside your perimeter, which is typically the endpoint. And there is one element which is inside your perimeter, which is your applications, data, servers, workloads. Now today, obviously, in this multi-cloud arena, your workload could be on Azure, Google, AWS, or on-prem. And the way we envisage security is by putting security controls in these two areas. That's what the security is. But largely, and more often than not, what we have seen is even if the security elements are there, like the endpoints have antiviruses, EDR, the network elements have app, they have firewall, and so on and so forth. We still see breaches happening, right? So why are those breaches happening, and how can we take care of those breaches is what I'm going to talk about. So typically, if you talk about a malware, right, today, and malware. Or a ransomware, right? The way which is most commonly known by most people is very, very disturbing for most people. And this malware or ransomware, right? They're spreading very, very fast. So let me take an example of a vulnerability called as Log4j. I'm sure while we had COVID, which had hit us, this was an IT COVID that hit us, right? It was like a IT pandemic, and Log4j vulnerability hit all of us while we were trying to battle out the challenges that pandemic had given to us. Now, while the Log4j vulnerability was so commonly known and so widely known, and I don't think there was any company on this planet which was not, vulnerable to Log4j, we still haven't heard about any huge attack, a malware or a ransomware attack that has actually been caused by Log4j, a huge attack, right? Or maybe there is one and not known to multiple people. Because more and more what we believe, what these ransomwares and malwares are doing is they're using these vulnerabilities to get access to your systems. And once they get access to your systems, they want to stay there. So, for example, if you want to visualize a malware or ransomware like a thief in your house, they're not coming to your house and stealing your your jewelries or your TVs or your laptops and desktops. What they're actually doing is they're actually sitting with you. They want these malwares and ransomware, they want to come into your data center. They want to stay there. They want to stay there for 90, 120, 180 days. They want to, kind of see what you're eating. They want to see what, what you're reading, what time you leave your house, what time you come in. And over a period of time, they're trying to analyze what is the most important data, what is the most important asset in your house. That is what these ransomwares and malwares are doing. Over a period of time, what we also saw was wherever a ransomware malware attack happened, we saw the number of hops that happened, right? And the way it spread. But now what we are seeing is more often than not is those hops have reduced to 1/10 or 1/5 of the size. It is reduced so much. And they're going with a very focused intent to attack what is the most important asset into your data center, like our house. So more often than not, and this is the philosophy that VMware believes is a malware is sitting with you inside your house. So how do you actually take care of that malware or that ransomware who's sitting inside the house? Because whether you like it or not, they're going to get through that security layer of perimeter and endpoint as well. So how do we take care of that security? We call it lateral security. So what we are saying is, assume if there is a malware that gets into your house, how do you contain it to the minutest, to the smallest footprint, so that he's not able to see what I'm eating, so that he's not able to see, what time my children are going to school. He's not able to see where I'm keeping my most important documents. So how do I contain that? And that's what, what we're going to discuss today is lateral security and how do we improve that. So if you have to look at lateral security for your data center, what are the elements in your data center? Like I said in my previous slide, outside perimeter, you have user who access the devices, and then the applications and data, right? That comes into your data center, and obviously it gets access to network. The applications more often than not is also getting complicated. Gone are those days where there were physical servers. From physical servers, they became virtual machines, and now we are breaking those virtual machines down into microservices, to Kubernetes clusters, to containers. So this application layer is now getting broken down, and then obviously the data, where your the critical, the most important element of your data center is now. So when you have all these elements into your data center, how do you actually take care of lateral security? That's what I'm going to talk about. So traditionally, if you actually had to look at all these elements in your data center and do and try to control lateral security, the way people could do is they used to do network taps, right? They used to do taps, or they used to put agents inside the workloads, and that is how they used to get access to this packets or to this traffic that is flowing from one workload to another. Now, if you were using an element like a network tap, what that network tap would do is it would connect to the physical switch, or it would connect to the physical port, and it would see what is the package that is moving through those elements. Now, like I said, gone are the days that we have moved from the physical server to virtual machine to Kubernetes. But when you pack virtual machines on top of your servers, what is happening is this physical network tap is absolutely invisible to the traffic which is flowing within the VM, which is lying on the hypervisor. In my example here, you're seeing web app and database VM on one single hypervisor. So this network tap has no visibility to how the packets are flowing between web and app and between the app and database, right? Because it is only looking at the packet that is coming outside the physical server and the packet that is going inside the physical server. Now we all know how Intel and AMD, has been progressing fast and packing up more CPUs, more RAMs, and so on and so forth, which means today we are packing in 100, 150, and there are a few customers who have seen who also pack in 200 virtual machines on a single physical server. So all that traffic which is flowing between these virtual machines is practically invisible to the network tap element that we have in our data center. And that's where NSX really helps you. So what NSX does is NSX is an element of putting in network and security into the hypervisor, which means it gets complete access to all these packets flows that are flowing within the virtual machine, right? So it is not very heavy. It sits inside the hypervisor. It's very, very seamless, and we can take that discussion sometime. But what I'm trying to have tell you is the visibility that NSX could give you to every flow, because every flow which is going into a virtual machine and coming out of the virtual machine, forget virtual machine, even if it was a Kubernetes cluster and if it was a container. So every packet that is coming out of that container and going inside the container is something that I get visibility to. It gives me access to all the conversations and all the connections into the data center, be it on-prem or be it cloud. That is the power of NSX. Now let me show you, visually how this works. So if I have to look at your typical private cloud proprietary appliances, and it could be public cloud as well if you want to, these appliances would look something like this, right? The security appliance, the firewall, an IDS IPS, a load balancer, maybe with a WAF, and then analytics with a network monitoring system, and telling me how the packets are flowing inside my data center. So what VMware has done using NSX is we've broken down these elements into small pieces of software, and we've added it into our hypervisor. Now, these hypervisors goes and sit in the server on which you create a virtual machines, which means every time you bring in a new server into your data center, along with the hypervisor, the security elements are inbuilt there. So security is built in rather than bolted on. And if you look at this image, right, this image is primarily been drawn as to give you an element of horizontal scaling that it is capable of, right? And that is the key element and the key advantage of the architecture that NSX has. But wait, let me ask you a question here. Have you heard about a term called Goldilocks zone? Right? Anybody, you want to raise your hands and talk and tell me if you know about Goldilocks zone? Nobody? Yeah, I don't see anybody telling you about Goldilocks zone. Okay, let me tell you what is Goldilocks zone. So Earth is actually in a Goldilocks zone. right? So what does that mean? That means that Earth is in a zone away from the sun, just right enough for life to survive, right? We have water in form of water. We have water in form of water vapor where we get our rains. We have water in form of ice where again it melts into water and it again feeds us back. Had Earth been any closer towards the sun, all that water would have evaporated, which means the life couldn't have sustained. And had we gone a little away from that Goldilocks zone, all that water could have frozen down into ice and never turned into water. So the life could not take place on Earth. So Earth is in that Goldilocks zone where we have life, water, plants, animals, everybody living together. The reason I talk about this is NSX is one element that helps you put security in a Goldilocks zone. The biggest dilemma of a security every time is, right, whether I put my security element inside the source, which is inside the workload, which can get hacked, or I put it outside. Right now, why these two questions is, if I put it inside the source, I get access to all the processes. I know what is happening inside the workload. I know what is running inside that virtual machine, who's installing what, and so on and so forth. But the biggest challenge is the moment the source gets attacked, if there is a malware and he gets root access, he will disable all the agents, right? Which means you have a CCTV camera in your room and somebody walks into your room and just breaks away the CCTV camera, and he will shut all the security element of that you have. And the other one is, if you keep this the security element outside the source, how outside can you keep it? How far away can you keep it? If you keep it too far away, what's going to happen is, like the example that I showed, when you have 200 virtual machines on one physical server, and if you keep the security element outside that physical server, and imagine a malware affecting one VM, within a second, that malware is going to affect all your 200 virtual machines, right? So if you keep it further from the source, the malware is going to spread fast. And if you keep it inside the source, the malware is going to shut it down. So how do you create that Goldilocks zone for security where the malware doesn't get access to your security and it's not too far enough so that the malware spreads laterally before the security element detects that you have a hack or you have a malicious activity going on in your data center? And that's what NSX does. So NSX is actually living inside the hypervisor, right? So this hypervisor doesn't provide any shell or any access to any malicious activity which is going inside the virtual machine. At the same time, every traffic that is going inside the virtual machine or outside the virtual machine goes through my software switches, goes through my virtual NICs. And I get access to those virtual NICs and I can apply security elements at that virtual NIC. So NSX gives you that Goldilocks zone in your data center to put security so that it is secure enough and you could take care or attack or contain any malicious activity that is going on in your data center. But we're not stopped there. What we did was we actually come out with a project called Project Monterey, and very soon we are going to go live on this. So what we're going to do is, we have these smart NICs, right? We are coming up with data processing units. So the NIC cards are coming up with processors. So what we are doing is we are actually going to take our hypervisor. We are going to port it on those smart NICs, on the data processing units, and we're going to run our hypervisor along with network and security elements there, which means any server where the smart NIC is capable or smart NIC is compatible, I can actually go and put my network and security elements non-disruptively without changing any IP addresses, without changing anything at all. So that's the power of NSX. That's the Goldilocks zone that NSX provides. So no overheads. So from that perspective, and you would hear this no overheads or no multiple times, and I'll tell you why. So NSX is the foundation of the multi-cloud infrastructure for VMware. Because when you think about multi-cloud, the first thing that comes to your mind is connectivity, networking. How do you connect these elements? How do you migrate your workloads? How do you secure those workloads? And NSX from VMware is the foundation there. What VMware has also done, adding to that is, we went ahead and acquired a company called AVI Networks. So VMware has also come out with a solution called Advanced Load Balancing, or Advanced ADC. What Advanced Load Balancing has been able to do is give you WAF and load balancing services to your applications, be it on-prem or be it on cloud. And there is no physical server or a physical appliance required at all. And last but not the least, using the same platform of NSX, we've been able to launch advanced threat protection services And I'm going to talk about all these three in detail in a few slides now. So NSX platform at a very high level, right? This is what it is. So at the left, what you see is the NSX data center and cloud platform. That's for your workloads sitting inside the data center. And like I said, the data center could be on-prem or cloud. The rightmost is the SASE platform. So we also have a SASE offering, the NSX platform. And in between, right now, this is a new element that we've been talking about. We call it ease, right? So we have SASE, we have data center, but we call it ease. And these are the edge components. And these edge components are typically required whenever a user is accessing the application. So, and NSX plays a very, very critical role here. And most often than not, like you see, you would have a distributed firewall, we would have an ADC, and so on and so forth. But NSX is largely a networking element with a capital N, like I said in my previous slide. And why do I say that, right? Because we say it helps you to do nothing. And nothing is when you can do a lot of things, right? So it helps you to do network and security with zero appliances. It helps you to do network and security with zero tickets. It's completely, fully, 100% automated platform. Zero network taps, like I said. And then last but not the least, and everybody is today thinking about implementing zero trust into their data center for their workload. It helps you to deliver zero trust. So that is the power of NSX, where how it lies in that Goldilocks zone, provides security and networking to your element. Now, how does this all work, right? I told you about the architecture. I told you how it sits into my hypervisor, how it scales horizontally, so on and so forth. But how does it actually really work? Let me give you an example here. Now, this is a traditional data center, like I showed in my previous slide, but this is more about an individual data center where the two left racks are full of servers where the virtual machines are. The right hand side are the racks where you have network racks where you have IDS, firewall, you have load balancer, analytics, the whole networking element that you have. Now, every time a virtual machine needs a network service for, say, firewalling, for, say, IDPS, for, say, a load balancer, or say, for an analytics, every time the packet is sent to that network element and then got back. So there is a element of hairpinning. And this is how, more often than not, the traditional firewall architectures for zero trust are implemented, if it's all physical appliance based. So what's happening is there is hairpinning, and if you have to insert any element of security, any firewall element, you have to change gateways, you have to change IP addresses, right? So it is disruptive. It is not dynamically scaling, right? Once you buy a typical appliances, network appliances, you have to use it till it reaches the peak of its throughput, and then you kind of scale, which is it cannot dynamically scale. There is a disruption there. There are blind spots, like I mentioned in my previous slide, and obviously it is expensive, right? Because as your left rack grows, the right hand side rack has to grow. You have to keep buying more and more firewalls and analytics and IDS, IPS. What VMware did with NSX was, like I said in the previous slide, that I took these elements of IDS, IPS and I put them in the hypervisor. So there is no hairpinning at all. So if a VM needs firewalling, it is right there inside the hypervisor. If a VM needs a load balancing, it's right there in the hypervisor. So, and that's how I spoke about Goldilocks, right? So the security element is closest to my workload, but not sitting inside the VM as an agent. So that, I cannot be shut. I do not provide any shell for anybody to execute any command. But at the same time, I get visibility to every traffic that is going in and out of that virtual machine. And like you saw, I also free up some data center space for you. I save cost, both CapEx and OpEx, and then obviously horizontally scalability, right? If you are adding more servers because we have to host more applications, the security elements get installed and come inside those servers automatically. So how do I operationalize east-west security using the elements that I showed? So, largely there are 3 steps for you to operationalize your east-west security, right? And I'm going to talk about those 3 steps in some time. So step 1, network and application segmentation. Now, this is something which is very, very well known to all of us, and we've been doing the network segmentation, VLAN, right? VLAN is something that we've been doing using, depending on production, DMZ, UAT, dev test, and so on and so forth. This is going a step further. This is going a step further wherein, for example, if you have a segmentation like this, where you have a development segment, where you have a web VM, an app VM, and a Kubernetes cluster, and then you have a production VM, which is typically a production segment where you have a app VM and a file server VM. You can stop access between these two segments. You can also stop, or you can also micro segment or apply firewall policies between the VMs which are lying in the same segment. So when we say micro segmentation, using NSX, you can apply firewall policies to the most minutest, to the most granular element of your data center. It could be VM or it could be container. That is the level at which I can go from micro segment perspective. But the biggest challenge from a micro segmentation is, does anybody know what is the biggest challenge for micro segmentation? Anybody? Okay, I don't see. The biggest challenge is micro-segmentation, right? And most of the CISOs where we've gone ahead and implemented micro-segmentation in NSX is they don't know which flows to allow and which flows to deny, right? It's actually very, it's actually very funny. I mean, if your applications are running, most often than not, you should know what are those flows that are required to make your application running, and what are the flows which are redundant, which are not required, and which needs to be stopped. But more often than not, we don't have that information because the legacy applications are running there for a very, very long time. So what this platform does is this platform actually also gives you visibility to the flows that your application is doing. So the way it runs is this: once you install this tool, right, it will give you access to all the network flows that are happening inside your data center, right? The green ones are the ones which are protected, which means they're micro segmented. The red ones are the ones which are not protected. And then there are, blue, which has certain other connotations. So basically, this tool gives you the view of all the flows that is happening to your application. And, one application will be having multiple VMs. Like I said, it could also have containers, it could have physical servers. All of those elements it analyzes and gives you this view. The user, what they have to do is, and very simply, right, this is the magic wand where you actually have to click and say start discovery. And it starts discovering for you the micro segmentation rules. So it's saying, this is your data center, and I've looked at all the rules, and according to me, these are all the flows. And now I let you see the recommendation. You can make changes. The user can make changes to this recommendation if you want to. But if you click on publish, just one button, and you see everything in your data center gets micro-segmented. So you're only allowing, from a zero trust perspective, you need to allow only what is required. So now you're only allowing what is required, and everything, all the other flows, all the other ports, all the other protocols, they're all blocked. That's how easy it is to implement micro-segmentation using this tool. That's step one. What's step two? Now, more often than not, what we have seen is the malwares and the hacks, they're actually coming in on legit protocols. They're coming in through legit flows, which means, and we did this survey, right? We actually did a research on an emotet malware. And what we realized was these malwares, they come through legitimate protocols. And the most often the most abused protocol is RDP. And can we stop RDP, remote desktop protocol? No, I think most of the admins use this protocol to take remote desktop access, to access the server, to access the desktop, and so on and so forth. So how do you do inspection? You do deep packet inspection into these flows. So micro segmentation will block the known malware or the known ports or known protocols, but the unknown ones, where the threat can come as a legit protocols, how do you do that? And that we do through an in-band inspection or a deep packet inspection. So what we do is we look at every flow, and actually I can apply IDS IPS to every flow. Now, IDS IPS is not new. You must be using IDS IPS on your perimeters, on your firewalls. But more often than not, the biggest worry in IDS IPS is two. One is the moment you enable your IDS IPS, your utilization hits through the roof, right? And second, the IDS IPS starts giving you so many alerts that you're confused which are the alerts that you need to focus on, whether they are false positives, whether they are false negatives, what do you do? What the distributed IDS IPS that we offer help you to do is we give you curated signatures. Now, typically an IDS IPS engine will have thousands of signatures. In an example here, you're saying 13,000 signatures. You might have 20, 25,000 signatures. What we do is we curate this signature. We look at a workload. Now, this is a workload which runs MySQL, which means there are just 26 signatures that needs to apply for this, right? Now, log4j, take up a vulnerability like a log4j. Now, log4j, at one point of time, I remember there were 26 or 23 signatures, give or take, that were applicable to log4j. Now, when there are only 26 signatures which are relevant for that traffic, why would I have my traffic go through 13,000 signatures, right? That's when the utilization peaks through the roof, and obviously it will create false positives. But when I make my MySQL traffic go through only those 26 signatures, the curated signatures, the chances are, and this is how we've seen practically in our customer environment as well, no overheads on utilization. The utilization doesn't shoot through the roof, right? It's just 26 signatures. It's not 13,000. And then obviously the false positives drop because only the relevant signatures are applied. So that's how we apply distributed IDS IPS. So every workload has its own individual firewall through microsegmentation, and to top it up, has its own IDS IPS that gets applied. So I look at every workload in your data center, and depending upon the nature of that workload, it could be an Apache, Tomcat, Oracle, Drupal, the number of signatures that is relevant to that workload gets applied. So like I said, I take care of the utilization peaks that you see into your typical IDS IPS firewall, and I also take care of false positive. So your IDPS engine is now 90% more efficient, right? 9x more efficient than the usual IDPS. And then the step 3. If you have to operationalize the east-west security, the step 3 is actually, you looked at step 1, where you block the known protocols and the known IP addresses. But your unknown ones, right, which comes through the legit protocol, you will block them through IDS IPS. But what about day 0? You'll also have day 0 in your data center. So how do you take care of that? So we have a solution about our network traffic analysis and network detection and response that helps you take care of the day 0 attacks as well. So what we do is through our NSX, there are sensors who can look at the traffic, and obviously we'll filter the traffic after microsegmentation, after IDPS. The only traffic that is left, we do analysis on that traffic, and then we try to see if they are belonging to a particular malware family, and then we kind of draw the chain in terms of how it has come into your system, how it is spread from a lateral movement perspective. We give you a maliciousness score, how risky this traffic looks, this behavior looks like, what antivirus family or what virus family or malware family it looks like, the behavior looks like. So all of these elements is what we can do through our NTA and NDI, right? Now, this screen is a very scary screen, and most often than not, some of us must have seen it when a ransomware hits us, and then we are asked for bitcoins. So we can do the 0-day attack analysis, how it has spread, which is the machine where the payload got downloaded to, and I will not go ahead and block it. I will give a risk score like I showed you, and then all of this data is available to the user or to your SOC team to understand the behavior and to kind of go ahead and block it. And I do file URL analysis, static file analysis, structural analysis, dynamic analysis. There are elements of this analysis that also run on my cloud. So this analysis is also part of the 3-step strategy that we have, and that's how you can actually go ahead and implement your microsegmentation in your data center. Now, while I was preparing my slides for this webinar, there was this VDI topic that also came in, right? I mean, after pandemic, VDI became so prevalent that most of the companies today, or 100% of the companies today, are deploying VDI. And this is a business reality, right? We cannot deny. Even we are attending this webinar probably from the comfort of our homes. So earlier, all these users were in offices, but and maybe some of them were required to travel, and that's why they were given VDI to access their machines from home. But very soon, what we saw was most of the users, or 100% of the users, started working from home. And all of these users, for a security perspective, they got access to the VDIs, which were sitting inside your data center after your perimeter firewall. And that's how they were accessing your applications. So in this, you see, there is a data center. There are VDI VMs where the user is getting access to. And these VDI VMs are now accessing your application and data, which means if there is any vulnerability, if there is any loose element here, right, the attacker can get through that desktop, come to the VDI, and the moment he is inside your data center, right, he can literally then start spreading to any workload that is sitting inside the data center. and the attacker can literally move freely inside a data center. What we've been able to do with NSX is, like we did firewalls for your workload, we can actually do firewall for your every VDI element as well. And these firewalling rules or policies can be defined on multiple levels. It can be a VM attribute, it can be a network attribute. Which network is coming in? Is coming in from a company provided network, or is coming from his home network? The application attributes, whether it's accessing Gmail or is accessing Outlook, or so on and so forth. And also user context, depending upon the, maybe there is a laptop which is used by his son for his school, and maybe that same laptop is used by him for doing office work, right? So if there's a user context, so how is it that you can put policies through all these attributes and define security? So you can decide, or you can logically segregate the VDI pools. Now, all these pools are sitting inside your data center, inside your network parameter, inside your network firewall, but you can actually make a logical pool. And this security can be extended to VDI, not only VDI, but also to the elements that help you provide VDI, right? You will have connection server, you will have connection broker, you will have multiple other elements. You might have a licensing server, you might have multiple other elements that makes your VDI work. So you can actually provide security policies to them as well. And every VDI VM, wherever you're creating a VDI VM, will come up with a firewall so that it can block the east-west security. So if there is a hack or a malware or a malicious activity going on in any of those VDIs, it can be blocked and contained to the individual element. So what are the use cases that we can help you deliver from a security perspective for VDI? Now, these are multiple use cases, and each of this is like a half an hour discussion. I'm not going to dwell deep in this, but just want to give you a view in terms of what all we can do. We can give you a layer 2 to 7 stateful firewall, an identity-based firewall, which is integrated with Active Directory. We can integrate with public cloud, partner integrations. If you're using any sorts of EDR or other partner security elements, and if they tell you, if an EDR tells you that there is a malicious activity going on in the desktop, and can give me that context, I can block that VDI VM. Distributed IDPs, like we already said, operational tools to make your life simpler and do automation, multi-site and federation. So you write your policy once, and any site and number of sites you have, the policy gets federated to all those sites. So there are multiple use cases that we can give. But one use case that I probably want to double click and show you was automation. Now imagine you can write all of these policies in software. What you can do is, and this, mind you, we were using this for our internal users, that people were getting onboarded during pandemic and they were not able to go to our offices, right? There was a single pool of VDIs, and a user comes and requests for a VDI. There is all these policies are already written. They just get attached to the VDI element, and a desktop is created and automatically, provided to that user, right? And it could be a finance, or it could be a development dev user. So anybody who could come into that single pool of desktops, and VMware also has a VDI software called Horizon, where we can do this, or we can also integrate with the other, VDI softwares in the market. But primarily what we are trying to do is, by automating or by giving network and security as a software construct, we can automate these elements and provide just-in-time desktops with complete network and security policy end-to-end. So in summary, when you look at a MITRE ATT&CK framework, right, or if you pick up any other security framework, and you try to see what are the tactics a malware uses to get inside your data center, to get inside your workload, and try to do a command and control, a C2C, and then try to exfiltrate. Most of these are the 12 tactics that MITRE ATT&CK framework talks about, and there are, I believe, 300 plus or some 200 plus techniques that this malware is used. So if you look at all of these tactics and all of these techniques, right, we can take care of most of them by NSX. So if the NSX platform is so wide and so comprehensive that we can provide you firewalling services, we can provide you web application firewalling, we can provide network detection response, IDPS, sandbox, and all of this without having to invest into any physical appliance, without having to getting locked into any particular cloud, right? So nothing like if this works on private cloud, doesn't work for public cloud, nothing like that. So all of these solutions are pretty much usable and migratable from any of the data centers. And that is the power of NSX. NSX, the network and security is in software, and that's why it's not connected to any particular platform. It's easily movable and migratable. So this is my last second slide. The next step, what I would recommend is if any of you, would be interested in knowing more about the platform, we can do a free assessment, a free of cost assessment, non-committal assessment. We'll do it free of cost for you. This is my name, my mail ID, my number, or this is also the link where you can go and request it for. This is what we do. We look at your east-west traffic patterns, and then we recommend what is the kind of security that you should have. Now, this is non-committal, like I said, so we don't charge you anything. It's free of cost. It can be done through our partners, or it can be done by us. And it's very, very easy. It's very simple. And mind you, this all happens inside your data center. We don't take any of your packets, any of your flows going onto cloud where analysis happens. We don't copy any of your data center traffic or packets or any other elements of your data center. All of that remains inside your data center. The tool that analyzes your traffic also gets installed in your data center. So it's very safe. There is nothing that goes outside your control. So with that, thank you so much for your time. I believe I was able to stay on time.